This video is going to look at disproving gravity again, and we're going to look at Newton's equation for gravitational force, and which is given by the universal gravitational constant multiplied by the mass of the object times the mass of the Earth divided by the distance between the object and the Earth squared. And the gravitational constant was apparently calculated by Cavendish, and it's an extremely small number. So here we have the Earth, and here we have a feather and a hammer, and when you compare the feather to the hammer, its mass is smaller, its distance to the centre of the Earth is greater, and therefore the gravitational force between the Earth and the feather is smaller. And when you compare the hammer to the feather, its mass is greater, the distance between the hammer and the centre of the Earth is smaller, and therefore the gravitational force between the hammer and the Earth is greater than that between the feather and the Earth. Here we have the globe Earth with its atmosphere. These are the molecules in the upper atmosphere, and these are the molecules at sea level. And the atmosphere is surrounded by the vacuum of space. So when we look at the molecules and atoms in the upper atmosphere, their mass is smaller, and the distance between these molecules and the centre of the Earth is greater. Therefore, the gravitational force is quite small. And when we look at the molecules and atoms at sea level, their mass is greater compared to those molecules and atoms in the upper atmosphere. The distance between the molecules and atoms here and the centre of the Earth is smaller, and so the gravitational force is greater. So we can see that the gravitational attraction between the gases in the upper atmosphere and the Earth are sufficient to withstand the vacuum of space. Since the gases at sea level experience a greater gravitational force, we can deduce that these gases will also be able to withstand a vacuum. Also, since liquids and solids have an even greater concentrated mass, they will experience an even greater gravitational force and also be able to withstand a vacuum. So let's put that to the test.